In this video we are going to look at another property of a parabola. Now this property sounds a lot more complicated, but it's a very important property, and coming up with the equation required is quite straightforward. Let's read the property. The equation of chord of contact xy. So we are looking at this chord xy. I'll explain what chord of contact is in a minute. xy of tangents drawn from an external point. So here's my external point, point P, and it has coordinates x1, y1. To a parabola x squared equals 4ay is given by. So essentially what this property is saying is, even though it's written sort of back to front, we are picking a point that's external to the parabola, sitting outside the parabola. We are drawing two tangents to the parabola from this point. Where the two tangents touch the parabola, we are going to join to form a chord. And the equation of that chord is given by this. Now, we've already looked at the equation of a chord. I can find the equation of any chord, but this is a very unique chord we're looking at, because we're starting from an external point x1, y1. So that the coordinate of that point is included here. Let's start. We have 2 points, x and y. Our coordinates for the 2 points are 2ap, ap squared, and 2aq, aq squared. Now, we've already found that the equation of a chord is given by y minus ap squared equals p plus q over 2x minus 2ap. Now, I will repeat myself again. This should not be memorized. If you are doing a question in an exam or solving a problem, this equation first need to be worked out, then you can use it, unless the question gives you this equation to use. But since I've already done it and the focus of this video is something else, we're going to use it straight away. The other thing we found earlier was that the point of intersection of tangents is given by a p plus q and a pq, and we did that in our previous video where we found x coordinate to be a outside of p plus q and y to be a pq. So if this is the external point, but our external point P is x1, y1, then x1 is equal to a p plus q, which means p plus q can be written as x1 over a. So I have this equation here, and in this equation I have p plus q. So let's take our equation and expand it and see what substitutions we can make. So we have y minus ap squared equals p plus q over 2 outside of x minus 2ap p plus q all over 2. So the 2's will cancel. I end up with y minus ap squared equals p plus q over 2x negative minus ap squared minus apq. So my ap squareds will cancel. I can substitute for p plus q. x1 over a, and my apq is y1 from here. So my equation will become y equals x1x over 2a minus y1. Rearrange and multiply, I end up with 2a outside of y plus y1 equals x1, which was the property I needed.